today's meetup, we've got Jay, Graham, and Simon who have joined us today as kind of our speakers, and it's going to be a discussion style. Jay also has a bit of a presentation, and we're looking at ontologies. An ontology was a term I first heard in university in a philosophy lecture. So I've kind of got a new definition of it, which I'm excited to see. So yeah, with that said, I think I'm going to hand over to Jay and everyone. Before I do that, this session is being recorded and it will be available on our YouTube channel. I will drop the link to our YouTube there if you'd like to, check out the recording later on for any information that you may have missed. But yeah, please feel free to ask questions, raise your hand. You can always drop them in the chat. But yeah, with that said, I'm going to hand over to Jay.
Yeah, I think that we've had many meetups on, discussing the concepts of concepts and how we describe and how we deal with, especially in the context of categorizing behavior and the ecosystem AI stack. And today is going to be slightly different in that we're going to go through some of the basic constructs again, and not in the context of philosophy or in physics or in various disciplines where this fits in the context of, let's say, the linguistics and the like. We're going to take a highly pragmatic view on how we see this and where we kind of see it going. So I asked Graham and Simon to join me so they can back me up, or not back me up. That we all three got our own views of the world that often, do not always synchronize, but that's the reality of how we see the world. So both Simon and Graham have got extensive backgrounds in the field. Graham is working on, with his architectural stack and with everything that he's been working on and trying to find better ways to describe business and enterprise, is very actively involved in this field. And Simon has, got a long history in, tech leadership and the like, but come out of, an intelligence world and so on. And even from when we met, he was always deeply interested in how things work, the technical details. In the last couple of years, he's been spending time at a company called Semantic Partners. So they essentially design ontologies for various organizations, including like the British government and the like. So the idea was that I'm the only one that is, I guess, probably the coder in the system. So I'm the one that I don't really care much about how you describe the description necessarily. I'm worried about how you turn it into something useful on the ground tech-wise for a client. So we bring different dimensions to the party today. So what might happen is that some of the conversations might go in different directions and we can decide how we bring it back on track. Okay, cool. So the big thing was that, and this is a debate that I've had with the confusion of ontologists, over time, and that is that in our world we deeply interested in the concept of the domain. So that means that how do I draw a broader picture of why I would need to consider an ontology for what I'm about to embark on in the first place? And the big thing for us has been around how do I take the understanding of, let's say, financial services as a sector, within that you've got an industry like, retail banking. Within retail banking, you've got, let's say a process for onboarding. Within onboarding, you've got a subset. So the idea is that there's this natural hierarchy that exists in the world that we know that is pretty well documented and well known to how we operate our businesses. But the language is still very confusing. And the idea behind the domain is that we kind of see that as the higher level. And then the ontology is a description of that domain. And then the big thing about the ontology is that it gives you the final structure, and we'll get to that in a moment. But then the building blocks is what we're truly interested in as people who want to make sure that it can be implementable and it can work for somebody on the ground, and make sure that there's not confusion. If you talk about a customer and I talk about a client, and somebody talks about a patient and somebody talks about a passenger, that we're all talking about the same thing, how do you create a common language and so on? So this gap between the ontology and the building blocks we see as quite an enormous problem in the industry as a whole. And then what we'll do at the end of the talk is just go through like some of the standards, because there are some really exciting standards out there, and it might be worthwhile. I don't know, Graham, if you wanted to show something practical. Simon, also, like the one we discussed, some of those examples are really useful around how this interface between an ontology and a knowledge graph and so on is affecting how we describe the world that we're in, and the notation that is used. Anyway, so that's kind of what the agenda is for today. What we'll do at the end, if we have a moment, I can just show everybody on ecosystem code how you can now upload an ontology. It will be able to generate an entire design for you. So it will then go from an ontological view into a system design, and a system design essentially become a spec-driven kind of approach that you can then generate an output that hopefully matches the ontology that you started with. So if your ontology is well defined, you already have an understanding of that, and we can get that thinking right. The idea is that can I produce a technological system that reflects all of the components that normally form part of that ontology. Okay, so the thing about a domain, and maybe just to give everybody a slight glimpse, and I'm slightly biased into product line practice. So it's a discipline that helps us to understand how we separate commonality from variability, and having a definition of a domain just makes sure that we have an understanding of how various elements within that domain fit together. So it's not just about the structure of what I'm looking at, it is also about the data, about the relationships, about the rules, about everything that essentially make up the total semantic landscape of what I need to focus on gets done in a domain definition. And so the idea is that we believe that the domain construct is a little bit underused in the context of semantic related research, and that it'll help you, and especially if you think about the interface between how we use generative models in the real world. And the great thing about generative models is that it's basically a popularity contest of taking what the world knows about a concept and normalizes it. And I've been working with another researcher. We've been working on this concept called the commemity, and that means that can you find the common language that exists within a domain, within a society, and use that rather than what maybe a technician or an academic or somebody has used to define that world. And that creates an interesting intersection, because every single vendor or technology-related company wants to invent something that's quite unique to their scenario to make them unique. So they hijack language the whole time. And how do we make sense of that in a common sense? And that's where we believe the ontology helps. And I think that the big thing about this, feel for how big this discipline is. I thought, Simon, what might be really useful for you is just to give this project you've been working on in the British context, maybe just give a quick glimpse of the extent of how that ontology is used across the entire government.
Yeah, sure. So the one that I've just finished working on is called the Information Exchange Standard, and it's an attempt by the UK government to provide a standard for how information gets shared amongst government departments. It's in its now 5th version. Around about version 4.3, they switched from an entity relationship model into a more formal methodology based on the W3C standards. And its origins were in the security services part of the UK government, so for police and military and so on to share data amongst themselves. So if you look at like 4.3, it's got this legacy. You can actually feel that it's there because it'll deal with arresting officer. So the role that I played is to start restructuring that so that there's a common piece and then domain-specific pieces. And then I did the deep dive into the building piece. And the attempt with the building piece is to give enough language to do a digital twin of the entire UK. And the purpose for that, and it's all public domain on the Digital Twin Program website. But the purpose of that is to adequately represent the installed base and the population of the UK in such a way that decision making can take place. And a lot of that, as usual, is to bring data from different large blocks of data sources together in such a way that these programs can make sense of them and that people can then build their functional requirements on top of that data set.
No, that's great. Simon, maybe you want to share the link for everybody just to go have a look at the extent of this, because I think that,
Yeah, I can do it in the chat here.
Because I think the thing what is interesting about that, and I went through it after you mentioned it to me, that even the Git repo with the standards and so on shows the extent, or essentially the amount of work that is needed to move from an entity relationship data only approach into an approach that describes an ontology. And that many of the things that are missing in the classical data world is now being taken care of. So that means that the accuracy that you can achieve in using AI tools to build on top of the ontology is far, far, far greater than just working on top of the data alone. So it does shift the thinking quite a bit. Gray, maybe you want to give a view on your thinking. You've been working on this too in the context of architecture and the like. So.
Yeah, I could do it at the end, or I can do it now. I'll just do a voice quick one now, and then we can share some slides at the end if there's time.
Yeah.
Over many years, we've worked on integrated meta models to combine all the aspects of enterprise architecture, enterprise modeling, and so on. So that covers business, application, information, technology, change dimension like program management, risk management, and so on. And we did those as fairly rich object type models for many years. And around about 2024, we had a really very comprehensive thing we call the holistic architecture language. But since 2024, we've been working to evolve that into an ontology-driven approach. So to anchor all the stuff that we've found in the enterprise space into more foundational ontologies, particularly basic formal ontology and unified formal ontology. Also drawing from Common Core ontology and stuff that's been done by the the object management group. So we've been working to ontologize the models in terms of rooting them in more widely and formally defined concepts. And we're getting there. We kind of at a point where we're hoping to launch a thing called Aeon, the Accessible Enterprise Ontology, which will be, it covers all the enterprise concepts that are common across different industries, domains, NGOs, etc., which surprisingly are not covered in the standard ontologies, but we'll get there.
I think the challenge generally is that there are just too many dimensions and too many angles for some people to make it practical. And that's why we kind of need to think of it like this. And that is that you got a journey that you're on where you use your classical, let's say, analysis and design techniques to decide on, kind of what raw data you have in an organization, how that gets used, and you start understanding how you can turn it into something that can help you with decision making, all the way through into a place where you can make sense of the patterns of execution and where potential challenges or opportunities lie in what you have. But at the end of the day, if you have 5 divisions who don't use the same language, don't describe things the same way, don't understand how to apply the same thinking, you end up with people running in all different directions. And we find that in like an ecosystem.ai environment, is that if you talk about, something like a recommender or a nudger or something that deals with, next best action, or every one of those disciplines are actually disciplines in their own right. But if people don't understand it, they just say, well, it's all just a recommender, and they just generalize it, where every single interaction point requires its own thinking and a set of rules and the way that you would describe what it means. If I want to have a certain message that's going to prepare you to receive an offer from me at some point that is a product, they are entirely different classes of execution. And they are in the same way that you think about when a personality gets applied on top of that, and I want to have a reliable approach to categorize you. The moment I categorize you, I want to have that definition being, well described and defined and reusable across various pillars of execution. So that's kind of how we see that. So that means that there's the age that we're moving into now, because we've got such a diverse set of options and views that exist. We want to come up with language that if I talk about a customer, or if I talk about introversion, that we both agree that in that context, for that purpose, in that particular place, it means something. And that's what I think within the ontology, the actual description that appears and how you define that then becomes the common standard that is applied across the entire organization. So I think that this move to meaning is quite a big focus going forward. And I think we're going to all agree, and at least all ontologists agree that is at a high level what it needs to do. The reality is that people use this all the time, because if you think of the hierarchy of, let's say, a family, a parent, a child, a sibling, a parent, whatever that might be, there's language that we use that if you say that this is my mom, or this is my dad, or this is my brother, or my sibling, there's a common understanding of that language. And we often kind of take it for granted, because in a business, if you decided to call your division a team or a strategic business unit or whatever the language that you use, it becomes very, very volatile, because you don't quite know what is going on. Like maps, maps describe concepts like cities and countries and road systems, and all of that is based on taxonomy definition. And in the medical world, this is an example that shown here, but it is far more complicated than what meets the eye. I think Simon, you also said that they were like, some of the stuff you worked on. I mean, it's enormous. Just that if you had to think of how many taxonomy elements were there in that one medical one that you worked on? I mean, that was
No, in the building one, there are like 460 classes. But a lot of them carry the role of classifications because the approach to classification was a bit off. And I don't want to go down that rabbit hole, but you can get some quite large ontologies. The domain ontologies tend to be much bigger than the base ontologies. So something like BFO has got far fewer classes and relationships because the idea is to have a very, very general purpose thing at the top and to use that to kind of provide a unified base on all the detail that follows below.
And I think the challenge is that if you are in an industry and you have a provider and you have a client and your client has got a customer, then you want to make sure that the language is uniform so that you all can integrate. And if you're going to get data sources at a technical level from various places, you want to be able to bring it into a place where it's going to make sense for you to be able to move it forward. And I think that's to Graham's point earlier. So these are some of the building blocks of an ontology. And I know that there are probably some things missing, but let's just talk about some of the key constructs. And that is that you need to have the categories of things. And if you think about how humans interact with the real world, there are kind of two major pillars. One is the ability to describe the physical world. So I want to describe my room. I want to be able to describe my chairs, my tables, and I want to be able to say, well, I've got a higher category of let's say furniture. Within furniture, I've got chairs versus tables, and within chairs, I've got small chairs and big chairs. So that means that separation of all of the categories in the context of the concepts are really important. And then the objects is to make sense of what the real components are. So if I have chair A and chair B, and even if they look the same, they might end up being two different physical objects. So how do you describe those in a world? Because you might end up with two different customers, with two different situations, with two different sets of products. And then the attributes that are associated with the objects. And this is quite a big debate in the context of how this interfaces with, let's say, the knowledge graph, because you don't always have access to all of the attributes at a moment in time. And the one fundamental dimension that all of this fits into is the concept of this evolving cycle of time. So let's say, in the context of a human journey, if I'm very young, and I don't have a job and I don't have a tax number and I don't have a bank account number and I don't have a phone number, I will still have attributes that describe me at a phase of my life that might just be my date of birth and my height and whatever that might be. And by the time I then acquire my first, or get my first job, or I open my first bank account, or I acquire my first car, or I acquire my first home, the attributes that are needed to describe you at that phase of your existence then starts dynamically expanding, and the relationships also start expanding over time. So you have expanding relationships, contracting relationships, and each one of those relationships come with a set of rules. So the rules could be that, am I allowed to? Do I interact with? Do I belong to? Do I work for? So there's a way that you describe using verbs, nouns, and adjectives, mostly verbs and nouns, how you interact with the world around you.
I think that's a pretty much good summary. And I think what the ontologies try to do is anticipate, even though the data might not be present, they tend to try to anticipate that this kind of data could exist. So you can imagine you described an individual going through a period of time. The ontology would try to anticipate that a person could operate accounts or that a person could own assets, even if that particular individual at the time you look at them doesn't have those attributes.
I think just what I would add into this, Jay, is when we talk about attributes, you've got named attributes like the person has a name, they have a date of birth, they have a, maybe a height or whatever the case may be. The attribute types also need to be described more accurately. So you would have to say that, the name is a string and the height is an integer or, a rational number or whatever the case may be. So there are also data types that come into it. And then also relationships also inherit from more generic types. So I might have a relationship type like knows about, or a relationship type like subtype of, or a relationship type like contains. And those have to acquire a precise meaning as well.
Yeah. And I think that one of the big debates, isn't it, is the concept of a set, because, should a set be an attribute? Because so you could have an entire ontology as an attribute that
Yes.
describe you know, a view of a subdomain, and that is what complicates things. And I think that, you know, how you then make that practical for implementation, you know.
Yeah,
you know,
I think
the
an important distinction to ontologies versus data models is ontologies kind of have an open world assumption, in that if we don't have something in the ontology, it's an unknown and it may just be out of scope.
Yeah.
In a data model, if we don't have something, it kind of doesn't exist to the logic, and it would assume it doesn't exist.
Yeah.
Also, ontologies, when we talk about a class, it's by characteristics and relationship or inference rather than definition.
Yeah.
So you can shift between classes, like you might be unemployed now, but you'll be employed later, and you know, employee might be a class, but it's inferred by the fact that you have a job.
Yeah.
Yeah.
I think what complicates it there is that you then end up with a hierarchy that will then help you with the typing, because the typing is what takes a lot of time to get right. And I think that, I mean, if I think some in our conversation about just like the procurement process and the government and the categories and so on, I mean, you got an enormously big, well-defined, so that if you got 10,000 suppliers, you want them all to use exactly the same codes and the same system. Okay, so if the meaning comes from relationships, and this is, you know, kind of a view that we take on a world that is quite strong, and that is that everything changes over time, and that means that there's always a moment before it exists, and that means that before it exists is either before the class exists or before the instance of the class. So that means an object exists, and then how they relate to each other over time essentially give you evidence of the actual concept that you are busy working with. So you might find that the rules that then emerge, or the rules that you, Graham, if I can use your language, that you're going to have to anticipate, need to make sure that you manage it within the context of the domain that you are in. So if you are in the domain of a bank in the context of a certain piece of regulation, in the context of a certain set of rules within a certain concept, that means that I have to do A before B, means that I mustn't allow B to happen before A. So I cannot open your account before you provide it with your domicile, let's say, or I KYC you. So that means that those rule definitions, there are some things that you want to make sure that's in your ontology that describe the absolute essentials of what never should break. And then you extend it over time. And I think that interface is what, from a code generation point of view, we are particularly interested in. If you have described your relationships well, and you have described all the elements of what you're going to be working well, and everybody agrees what those are, then you'll be able to move forward. And if you don't, you then have to think why. So the only example that I can think of why is that if you think of the construct of novelty for a moment in the context of product strategy, if I'm a telco company and I sell you, you know, 1 unit of value, so it could be a bundle or data point, whatever it might be, I sell you 1 unit of value, and that 1 unit of value comes with 100 points that you're going to access it for. That means that you pay me 1 and you get 100. If I want to make it more novel, I might want to get you to pay 1.1 and you get 110. It's still within my economic model. But now instead of calling it product A, I'm going to call it product B. So that natural evolution of creativity and of novelty is something that I think sometimes bloats your ontology. So where do you place that in? And that's where the knowledge graph becomes quite important, because the knowledge graph will start to give you an understanding of, and I've been doing a lot of thinking about that knowledge graph as data. And I know that there's quite a few academics, and after my search, I come out of a world where the knowledge graph is a separate class of description. But the ontologists, you know, that the confusion of ontologists believe that the knowledge graph is the data, and it just makes so much sense, because if you have an ontology that's been implemented in a correct fashion, the graph naturally will show up centralities around the areas where those fit. So that means that if the knowledge graph is the data, how will I then describe over time concepts like novelty? So that means my centralities will move away from, let's say, people buying something that I used to sell for the last year. Now that I changed the name of it and I made slight changes to it, I can sell it more. I can then track a new kind of product, but I still want to know the lineage. And that lineage you can then define as a relationship in the ontology.
Yeah, it's a derivative.
Yeah, I think the nuance in what we tell our clients is that, especially in the W3C standard stack, the data and the ontology live very happily together, which is hugely novel in a corporate setting where you tend to have like Snowflake, and then some Snowflake make spreadsheets and then put all of that content to the best of their abilities into Calibra, and the whole thing then collapses in a heap. It's much more useful when your data and your ontology that gives you the meaning of that data live in the same box or in the same kind of technical environment, because you can do the kind of things that you alluded to, because you're then able to say, well, that product, I know exactly how it's defined. These are all of its attributes, and these are all the sales in the last period. And that's all living in graph space, which makes traversal of that almost trivial.
Yeah. And I think for us also, the thing that is deeply interesting is that if I'm going to design an experiment because I've declared that maybe I can learn more by declaring that I don't know, if that makes sense, that means that the experiment will then help me to define what possible variations I should be commercializing and what I should be converging on for that moment in time until something new comes along. And because humans are continuously interested in novel ideas and novel concepts, novel products, pricing, new colors, new shapes, whatever that might be, you want to find a way to have that lineage. So I think that is the big thing that I think an ontology can assist with, is that you want to be able to track in your digital twin. Can I run a digital twin that can potentially predict where shifts could be because I've been tracking a certain cohort for, let's say, a year or a certain period of time? And at a point in time, I want to then separate the cohort into subgroupings based on learnings that I got through my digital twin that will then initiate my experiments. But if you don't have a common description, common understanding, you don't know what you're tracking, I mean, you're never going to know, and especially in the context of multivariate implementations, because in an A/B environment, it's easy. You've got 2 tests and it's done. But if you've got multivariate, hyperdimensional spaces, that complicates the measurement of success enormously. You just don't know if you're ever going to get there. Anyway, so just a point on some of the things you've been thinking about in our space. So here's a kind of an intersection of why it matters in the context of AI. And I think that the big thing is, how can it help us get an understanding of the context that we're in? And I think that the one thing that we do know now is that most, including small generative models, are incredibly good at generating common knowledge, because basically those models are designed to converge on common understanding of the data that was used to create those. So that means that I think that understanding context and providing context is enormously assisted by using these tools. And then the ability to then connect various kinds of concepts into a way that you can describe them properly so that you can reduce your ambiguity is going to be an ongoing, I think, benefit of trying to find models that are highly specific to this. So what we've been doing in a code context, maybe just to kind of give our angle, is that, if you had to use, and this is kind of one of the go-to tests that I always like to apply, if I had to say to my model CRM and nothing else, so if I put just those 3 kind of characters, that is an acronym, and I stick it into Opus 4.8, or I stick it into Mythos, or I stick it into OpenAI's 5.5, or in DeepSeek, whatever the models are, they all will, within a very, very narrow focus, produce basically the same kind of output. It is because the world has already essentially self-reviewed its own understanding of that acronym in the context of where it gets applied. So that means customer relationship management, in the context of having a lead that becomes a customer, that goes into a contract, that has got a target campaign, that language is incredibly well understood by the world at large. Where things get complicated is when you now want to start applying that in the context of your own business. So the idea is that, can you use AI tooling to enable the reasoning? And then can you get a lot of the decisioning and the pattern understanding of what goes on in what you are looking at before you extract the core concepts? And that's what humans find themselves, if you think about individually, we find it pretty difficult to do. And then lastly, how do we then build an ability to dynamically share or use it in various contexts? I think in our context as well, in the ecosystem code environment, the idea is that if I have an understanding of the world, and that means that, let's take the CRM example again, or ERP, or I want to do an accounts receivable or accounts payable, or let's say anything within the financial discipline or the product line discipline or whatever that might be. The concepts are well defined. So can I provide the shortest possible input to get the maximum possible output? And that's why at the moment, the backend engine that we use has got a multi-tier decisioning capability, so that if you just provide it with a single word, that will be able to use it. if you give that single word with a variation, so you can say that I want CRM for financial services, CRM for, customer retail, or whatever it might be. You provide the domain context, and the idea would be that the output can be used as an ontology. So the way that we do it at the moment is you can go to your custom code, you can generate one of these, and you can just say export ontology, and it'll generate the ontology for you. There's still some work to be done. This release became available literally a few days ago. So I'm talking about something that is completely new, but the one that we tested was pretty good. So it did create quite a good structure of what that ontology.
Yeah, but I think, Graham, you'll know that you and I have always shared this idea that there has to be something that a business would recognize from which you can generate systems. And the experiment that Jay's running is the ontology that thing, which I think is really super
Pretty much.
interesting.
Look, it's not trivial. You have to have a very well-defined ontology with a lot of constraints and a lot of rules. But given that, yes, I think you can generate probably 80% of the functionality. What you then need to do is engineer the environment such that you have human in the loop reference when there's something unclear, but that you then capture that and enrich the ontology so that you eliminate those edge cases progressively as well.
Yeah. And I think that our approach from a scaffold point of view is saying that if I'm going to apply good software engineering practices and system design principles, do I want a person later on to break the rules of how the security is going to work, how the data is going to be accessed, how you're going to deal with, blocking, and how you're going to deal with issues and scalability? Probably not. So you don't want your ontology to describe a lot of those. You want to describe the semantics. So the way we do it now, once you've generated an environment in our world, and you just ask Claude Code, even on your local, if you're even on your local model, to explain the extensibility framework, it does exactly that. It extends it based on how an ontology could be mapped onto the generated core capability. And we're going to work on that a lot more going into the future. So the idea would be that you can, let's say you target your generated system into, like, let's take the CRM example. And let's say that you are in CRM financial services and somebody's in CRM in selling, building products. The one deals with a physical product that is tracked, and I want to know about it, but the other one deals with the inconsumable service. The idea is that the core capabilities of the fact that I need to record a customer and a time, when I run campaigns and so on, will be same. And then I can extend it on top of that without breaking the base. So that whole commonality, variability, separation, I think, and especially the way that you inherent in an ontology from a higher level of definition, if you can replicate that in your code design almost in the inverse, so whatever you inherit from becomes your framework that you run on, and whatever the variabilities are, you should be able to describe yourself dynamically and then generate on top of that without breaking the base, is kind of where we would really like to end up. We're almost there. I think we're running hundreds of tests to try to figure out if we can get that completely stable. But there are a lot of releases that we're pushing out at the moment that deals with that. Just if you ask it, tell me about the extensibility framework, you can already see that your hooks are there, everything is there. You can extend it in any way, and you can, without breaking anything. And I think that's the big part. So if your ontology can become that total language, and it's well defined, you should be able to accelerate your implementation. So, it's not really worth going into a lot of detail over here, but I think that the basis of the traditional AI around, dealing with, pure historical patterns and, decisions in black boxes, and the way that you can kind of think about how reasoning takes place and how you start from scratch. In the ontology-driven world, the biggest differentiation is the fact that you want to start from a common set of domain concepts, and that domain that you're in and the discipline that you're in helps to describe what it is that you need to do. And if you can get that domain to be drawn broadly across, let's say, an entire sector, and that's why, like some of the conversation about, they said that the government, it's a fascinating one, because, if you have everybody that's going to supply, a pipe fitting for, a certain water system, and you've got 1,000 suppliers, you would want them all to know exactly what the name of the fitting, what it looks like, where it fits, what its code. You want to have a common understanding of what that is. Otherwise, you'll never get the right kind of product supplied, and to get them correctly. So that whole traceability and ability to work that out over time is an enormous benefit. And the idea is that the AI tools can help you to what those patterns of variation are. and which areas you then need to focus on fixing. And if that domain's evolution over time, and I'm particularly interested in the evolution of the graph, the evolution of how the structure that was formed at time 0 changed at time 1, time 2, and time 3, because it's in that structural change that you can essentially calculate your volatility. Because if your change in a domain that is supposed to be standardized is not slowed down, that means that you are not doing the right thing. But if you can get a common understanding and propagate it, your volatility in the areas that should be shared should be, stable. So yeah, so that means that the changes over time is quite a big focus. I know
I think it's true to say though that there are 2 time cycles, certainly in the world that we work in. The first time cycle is just data, and generally we are dealing with integration problems, so data comes at a particular rhythm. Each rhythm is a slice of reality at that point in time, or as recorded in those systems at that point in time. So your data does keep changing, and therefore the resulting graph morphs continuously through time. And if you are receiving data from sensors, your frequency is quite fast, and if you're receiving month-end data from ledgers, your frequency is like month-end. Having said that, the ontology generally evolves as well, and that's at a slower pace. But what we do is we try to introduce at the ontology level the same disciplines that you've got at the software level for continuous integration and continuous delivery. So there is processes that we use to say, well, this is novel data, it doesn't fit the ontology, this is how you change the ontology, this is how you regression test those changes, and this is the impact that it's had on your pipelines, and so on and so forth. So there is definitely these 2 time kind of cycles, and you do need disciplines around it, and often we try to mimic the software disciplines for that.
Yeah, so it's basically a configuration management problem either way, because the ontology is a reflection of your understanding at the point in time of that business's reality.
Yeah.
And the unfortunate thing is, and I've had this conversation with clients over time, people should be versioning their organizational structures. So that if they change a business process or a structure, they should version them all, but most people don't. They just start we are on a thing called digital transformation, and off they go and they start transforming, and they're 6 years in or 1 year in, and you ask them, so what version are you on? I mean, are you sorting out your defects? Have you learned anything from what you did before? They said, no, this didn't work, so we just got rid of some people and changed them, and then you get hysterical hyper-inactivity setting in, and then it never gets done at the end of it because you never versioned anything. So Simon, I mean, that's exactly the point, isn't it?
But we've got many PowerPoints. What's the problem?
Yeah, and a PowerPoint version 1 crisis is even bigger. It's my endless bugbear in life, and that is that every time somebody sends me a deck and it's back to version 1, I go nuts because I say, well, that means you've never ever done this thing before. It just yeah. But it is but I think not many people think of this time slicing in a way that is going to give them continuous and successful learnings in the future, and that's hopefully what a lot of the AI tools will alleviate and assist us with. In software engineering, if you have a single ontology and a well-defined view of the world, the idea is that your domain modeling should be a representation of your system architecture. So if you work within a world where you want a separation of concerns in a certain way, you want to be able to deal with that in a reliable fashion. And that means that the way that you deal with what's not visual, and ideally in a world of modern data, everything that you do should have a headless implementation so that it's accessible through an API or a GraphQL kind of backend. And that means that the database at the end of the day should really just be around the highest level of convenience with maximum performance. So we found that we keep on gravitating towards NoSQL environments. Doesn't mean that SQL is not a good place to be, but it just means that the database world, and Graham, I mean, your view on the object database for your implementation, is fit for that purpose. So the idea is that I think that people often make a decision based on the wrong criteria for that kind of thing. And then the knowledge graph and how that fit within, your total organization is also, I think, largely misunderstood, because the way that we've been using it in the context of, if you look at a directed graph or static and dynamic graphs as like a graph classification approach, is that almost all knowledge graphs can be bidirectional, although most of them are directional. You know that most of the nodes are not necessarily typed. When you start with a graph like that, you could type them over time. So there are still some differences in opinion about how that gets implemented. So if you think of tech providers like Neo4j and the like, you have to have a node with a very specific type and with a very specific purpose, where at the end of the day, the graph's purpose is to give you a better representation of the real world and give better representation of the data that you have in your organization. So if you've graphed all of your customers with the products that they've got and the times that they've interacted with you, and you then do that in time snapshots, you can calculate your structural differences over time and your structural shifts. You can predict when people are going to leave you or not leave you, not necessarily just based on, a classical machine learning, learning problem. You make it a graph problem, an intelligence problem that is far more accurate in its outcomes. So I'm not sure if you guys wanted to comment on this.
I like to distinguish that kind of analytical graph that says I'm looking for centrality and I'm running numbers against that, the real analytics, as separate from what we'd call a knowledge graph. But the only issue is not the word graph. The issue is just like where you touch the word knowledge. So I kind of honed in on to get my own mind right, calling the analytical one an analytical graph, where you are looking for those things through time and you care about whether it's a DAG or not a DAG, directed acyclical graph, because the algorithms differ and they differ in the interpretation as to whether it's directed or acyclical, etc., versus the graph that is a representation of the data. And so we must just be careful not to trip over making assumptions about what goes on, like in the early stages, just go overboard in elaborating what do you mean by graph.
Yeah, I think that the language has been morphed into a far more broader implementation than what we've used it in the past. I find, at least based on my interactions now, and even our conversation yesterday was, that the knowledge graph as a purely dynamically expandable and contracting representation of the real world is the way that we use it. So that means that the purpose of the analytic is to influence the outcome of where you want the graph to go. So if you have high degrees of centralities around, let's say, a certain product that you're selling or a certain message that you're pushing out into the market, and you want to shift that centrality somewhere else to a different product or a different message, or you want to take away that centrality from a competitor, you use your centralities. So that means if I take, let's say, a click that's normally finding where a lot of nodes link together, and I relate that to the boundary spanners, and I'll then take a betweeners centrality, and I take those three together, typically the outcome will be that I'll go after the betweeners with the people with a high degree of click, because I know that I can then circumvent what other people are doing. So even just using that language in the graph world is not typically known to ontologists, because the way we apply it is to influence how the graph is going to change the structure over time. And that means that the structure is more important than the definition of the structure. And I think that creates confusion. Simon, I think that's the thing, that where the ontology world is very interested in defining the class, the data point. It's very, but in the knowledge analytic, if you like in your context, the analytical world, the way we kind of use it more, we're more interested in why that name, that class appeared in the first place at that point in time, and then what appeared at time point two.
It comes back to data first or schema first. Schema first is nice and manageable and comfortable because we can think about things in categories and what we believe we understand, and we can manage things kind of top down. Data first is the other way around. We collect a bunch of stuff and then we try and make sense of it. And that's what a lot of organizations are facing when you try to systematize knowledge that's in documents and things like that, and not in databases, but in emails and documents and stuff like that. Or you go process mining and you see, what really happened as opposed to what was intended. So then you've got to collect the data and then try and impose order or discover order, and it's the other way around.
Yeah, and I think that is the thing, is that the reality of the analytic of the enterprise is that even if the data is disparate, structured, unstructured, the evidence of a class of concept becoming available at a moment in time there was a reason why it became available, and there was a
Mm.
reason why it disappeared. And that means that can I pre-predict the event that's going to cause the issue, not the fact that the issue has happened. And that's why this example of churn and whatever it might be, or is kind of it's not a data science problem. It's got nothing to do with it. It's a behavioral science problem with a graph that gives you the evidence. So that means that the question then is, and this is the conversation that I think I definitely want to, and Simon, we'll create a working group brand with it to figure out how do you define the dynamics of the knowledge graph in an ontology, and the fact that there must be a class called change that has got a type of class where the class is the class type emerges at a point in time and then disappears later on.
Okay, so graphs, multi-graphs, hypergraphs, nested graphs, metagraphs, all of them is also multi-level. So you can have things which are definitional and instances at the same time.
Yeah.
So you're not restricted to your 4-layer schema model.
Yeah.
And we've also added to that some ontology tracking, versioning capabilities. So we're just at the point now where we're starting to put models and model language on top of that. But that's the kind of environment that you need to get to what you're talking about.
I mean, maybe in a
because
we can unpack that. It'll be good to go into some of the detail.
because sometimes the classes are notional. Coming from a database world, you think class equals schema. Coming from the ontological space, a class can be notional. In other words, a sibling, for example, is a child or a person who shares a parent with somebody else.
Yes.
Now, from an analytics point of view, I may say, I want to go and find siblings because I want to give siblings at a school a discount. But that may not exist as a structure in the database until you want to do the query, right?
Well, let me see. That's the Graham why we are NoSQL people. That's why I like this conversation in. So I'm not a SQL fan at all anymore. And actually, I always kind of joke, and Ramsey, we always kind of joke about it because it's the one thing that we now know is that the world's continuously changing. You want to be able to have, so we add dynamic attributes, structures, and then you have the ability to process it, at scale. Means that why should you have to stick to a schema? Because the schema comes purely out of the 1950s because COBOL needed it. And the SQL world with CJ date just took the same construct because you had technological constraints. Yeah, so the next thing is just to talk about the standards in the context of how these are defined. And I think that the broader world of the semantic web is a pretty big definition in the context of the Web 2 movement. But it's just that each graph type comes with a specific approach, and they all go through multi-versions of how they get updated. At the moment, we support all three of these in the context of our code generation. So we are working on extending the core capabilities because everybody can create their own substructures. And actually, in fact, the one that we worked on now, Simon, was on the role definition component to say, can I take a role that is defined in the ontology and then when you generate the ecosystem output, the ecosystem code output, that it will then go and create different roles with only what those roles were assigned to in the ontology. So that means if the user thinks through that, the person that is the clerk that is only allowed to see it, creating the transaction and using the customer, and the person that is the administrator can add the customer and only look at the transaction. So you've got all of those rules predefined is kind of what we're on journey to do. So the idea would be that you should be able to define that in your ontology.
I just want to give some flavor if there's time. I know we're right on the mark, Jay. I think, and I put it in the chat, the standard is a little broader than what's here. So I'll just elaborate for the recording. F stands for the resource description framework. And it's one of Tim Berners-Lee's early standards on which the internet was built. Then there's RDFS, which is a schema language that lets you define your expectations about RDF. And then there's L, which stands for Web Ontology Language. Now, all of those are standards, and they all like specifications more than anything else. There's a companion one called SPARQL, which is the query language that works with that. Turtle is different because it's merely a representation.
It's just a format for RDF, really.
Correct. Yeah. So it's a serialization format, and there are many different ones that are fully interchangeable amongst each other. We always use Turtle because it's both human and machine readable. So it's like that very nice in-between space that a
Yeah.
human can read it without falling apart. And
Turtle is kind of like a JSON for
Correct.
semantic knowledge.
correct. Yeah, it's a pretty good way of describing it. Yeah.
I think just to add to that as well, Simon, these still also mostly describe structure. They're also the description logic languages and the logic languages and the constraint languages. So you've got LDL, which is different. And
And you've got
they help
SHACL, the shapes
and
constraint
then
language.
SHACL, which is a constraint language, which will say things like, if you've got relationships between people, you can't be your own brother, you can't be your father's brother, and things like that.
It's coming from the relational world. You'll find a lot of common understanding about what's in SHACL because you've got things like cardinality in there and the way in which things are restricted within fields and where lookups are going to take place and enumerations. And so SHACL's a good place for people who are coming from.
But I think that I could
relational.
recommend that we, if you guys are okay with it, that we have a separate session on the interpretation of the standards and the application of it, and then how that can be used in the existing code world. I mean, it might be worthwhile maybe to have a deeper conversation on that, and just on, because I think the thing around the interface of the domain, the ontology, and the knowledge graph, is also an ongoing discussion that we can unpack. Because I think that at the end of the day, the examples of what exists and the various types that are out there and the campaigns that are going on to design better ontologies are just enormous. So I think people are trying to find answers to a lot of those, especially the diverse approaches that are being applied. So the idea behind today was maybe to show one or two of those things, but for those interested who do have access to code, you can go and apply that or generate that. And we will be publishing a handful of example ontologies that will happen hopefully in the next few weeks. Also, Graham, Simon, you did contribute one, Simon, that I can share. And I don't know, Graham, if you wanted to share one with, we can discuss it.
Maybe some outputs in terms of the analysis we've been doing towards the common ontology that we're creating. Yeah, because what we had to try and do is figure out what's common across the ontologies, what's common across the enterprises in different domains, and then try to figure out also the relationship types that are necessary to support the enterprise domain, and the data types. So you're dealing with entity ontology, relationship ontology, data type ontology, and bringing those together was non-trivial.
Well, thanks, Simon and Graham. Always love chatting to you guys about these things.
Pleasure.
So thank you so much.